So now we're going to start section 5.8, which is about inverse trig functions. So we're going to start by recalling some facts we knew about derivatives of inverse trig functions. So in particular, the derivative of arc, the inverse sine function, is 1 over the square root of 1 minus x squared. And the derivative of the inverse cosine, or cosine, is negative 1 over the square root 1 minus x squared. So those are two things we knew about derivatives. And we can take these and kind of other things we knew about inverse trig functions and get the following formulas. So the first one is that the integral of dx over square root of a squared minus x squared would be arc sine of x over a plus c. If a is 1, that's just comes from this formula up here. But if a is not 1, you have to do a u substitution to get this formula. The second one is that the integral of a squared plus x squared, this is 1 over a arc tangent of x over a plus c. So this comes from the derivative of arc tangent. And then the third one, and our last one, will be this formula. It's 1 over a arc secant of the absolute value of x over a plus c. So all of these are formulas that we're going to end up using in this section, so you might want to reference them, write them down so we can see them. Let's look at our next example. We're going to compute the integral of dx 4 minus x squared. So if you look here, you can identify our value of a. A is 2, because 2 squared is 4 here. And if you look at our list, which one does this match up with? It matches up with the first one in our list. So you'll get arc sine of x over 2 plus c. And there's our integral right there. All right, let's look at another example. Let's compute the integral of dx is 2 plus 9x squared. Oh, I already have a dx. There we go. So if you look back in all of our formulas, the x squared term doesn't really have a coefficient. So I need to get rid of this coefficient here of 9. So the first thing I'm going to do is I'm going to rewrite that as a square. It's 3x squared. And then I'm going to do a u substitution here, u being 3x. So I'm going to have a 1/3 du is dx. So when I make this substitution, I'll get a 1/3 1 over 2 plus u squared du. And from here, this, if you look back, which one does this match up with? Well, maybe first we'll identify a. So if I look here, that's a squared. So a would have to be the square root of 2. And if you look back, this one doesn't have a square root in it, so it matches up with our second one. So we're going to plug in to our formula. So I have a 1/3, and then here it's 1 over a, 1 over the square root of 2, arctangent, and it's going to be u, because that's our variable here, u over a, the square root of 2, plus c. And the last thing we need to do is get rid of that u that's up here. I need my answer in terms of x. So I'm getting 1 over 3 square root of 2, arctangent of 3x over the square root of 2 plus c. And there is my integral right there.